JEE Advanced 2025, Paper 2, Physics, Question 5. Here is the setup. We have a neutral conducting sphere of radius 10 cm. A positive point charge Q equals 10 to the minus 8 coulombs is placed 20 cm from the center. Due to electrostatic induction, negative charges gather on the near side and positive charges on the far side of the sphere. Now the sphere is grounded. Positive charges flow to the ground, leaving only negative charge on the sphere. Then the ground is removed. Finally, the point charge is moved 10 cm further away, to a total distance of 30 cm from the center of the sphere. Here is the question. A positive point charge of 10 to the minus 8 coulombs is placed 20 cm from the center of a neutral conducting sphere of radius 10 cm. The sphere is grounded, then the ground is removed, and the point charge moves 10 cm further away. Given 1 over 4 pi epsilon naught equals 9 times 10 to the 9. We have 4 options. A. Before grounding, the potential of the sphere is 450 volts. B. Charge flowing to ground is 5 times 10 to the minus 9 coulombs. C. After ungrounding, sphere charge is minus 5 times 10 to the minus 9 coulombs. D. Final potential of the sphere is 300 volts. Let us review the key concepts. First, electrostatic induction. When a point charge is near a conductor, it causes charge redistribution on the surface of the conductor. Second, grounding. When a conductor is grounded, its potential becomes zero. Charges flow between the sphere and the ground until this condition is met. Third, the potential of the sphere equals kq over d, due to the external charge, plus kq over r, due to the charge q on the sphere itself. Here q is treated as uniformly distributed at radius r for potential calculation. Fourth, once the ground is removed, the charge on the sphere is fixed. If the external charge moves, only the potential changes, not the charge. Let us check option A. Before grounding, the sphere is neutral. The induced charges on the surface redistribute but have zero net charge. For a neutral conductor, the potential at the center equals the potential due to the external charge alone. Because the net induced charge is zero, their contribution to the potential at the center cancels out. And since the conductor is an equipotential body, this is the potential everywhere on the sphere. Plugging in the values, V equals 9 times 10 to the 9 times 10 to the minus 8 divided by 0.2. Computing this gives us 450 volts. So option A is correct. Now option B. After grounding, the sphere potential becomes 0. We write kq over d plus kq over r equals 0. Here q is the charge that remains on the sphere after grounding. Solving for q, we get q equals minus qr over d, substituting, q equals minus 10 to the minus 8 times 0.1 divided by 0.2. This gives q equals minus 5 times 10 to the minus 9 coulombs. Since the sphere was initially neutral, the charge that flowed to the ground equals the positive charge that left 5 times 10 to the minus 9 coulombs. So option B is correct. Option C. Once the ground connection is removed, no more charge can flow. The charge on the sphere remains fixed at minus 5 times 10 to the minus 9 coulombs, regardless of any subsequent movement of the external charge. So option C is correct. Finally, option D. The point charge has moved to 30 cm from the center. The sphere still carries minus 5 times 10 to the minus 9 coulombs. The potential is kq over d prime plus kq over r. The first term gives 9 times 10 to the 9 times 10 to the minus 8 over 0.3. Which equals 300 volts. The second term gives 9 times 10 to the 9 times minus 5 times 10 to the minus 9 over 0.1, which equals minus 450 volts. Adding them, V equals 300 minus 450, which is minus 150 volts. This is not 300 volts. So option D is incorrect. The correct answers are options A, B, and C. Option A, the potential before grounding is indeed 450 volts. Option B, the charge that flows to the ground is 5 times 10 to the minus 9 coulombs. Option C, after ungrounding, the sphere charge remains minus 5 times 10 to the minus 9 coulombs. Option D is incorrect because the final potential is minus 150 volts, not 300 volts. Here are important tips for JEE Advanced Electrostatics. First, whenever a conductor is grounded, set its potential to 0 and solve for the induced charge. Second, the potential of a conductor is the sum of contributions from all charges, both external and on the conductor surface. Third, after the ground is removed, the charge on the conductor is fixed. Only the potential changes when external charges move. Fourth, for a conducting sphere, you can treat the uniformly distributed surface charge as concentrated at the center for calculating potential outside. Fifth, in multiple correct questions with negative marking, always verify each option independently. Never assume a pattern in the answers. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.